Hello, everyone. On the agenda for today, we're going to go ahead and we're going to finish notes 3.4. We're going to start notes 3.5, graphing x-intercept form. Reminder, the final quiz for the semester is next Thursday. That should say 12:10, not 2:10. By the end of class today, you should be able to graph parabolas in factored form. That is your goal. So we're going to start off by looking at this problem. 4 students try to write an equation for the graph below. Who is correct, if any? Explain to each student who made a mistake why their equation is incorrect. So really quickly, what I'm going to do is just remind you that when we're looking at this graph, here is my vertex point. And if I want to label my vertex point, I should be labeling it as 2, -6. Because pay close attention to the fact that the graph here, when we're looking at our y-axis, it is changing by a value of 2. Because notice our second line is -4. That means that each one of these lines is worth 2. So our scale factor is 2. That means that point there is at -6. So keeping that in mind, who is correct and why, if any? So what you should have said when you looked at that problem was that everyone was actually incorrect. Because if we look at Madeleine's solution, remember the equation for this problem, it's x minus h squared. So given that our h value, what we talked about, our vertex value was 2, that means that this should be saying x minus 2. Remember how you kind of have to think opposite for those inside values? So Madeleine's mistake was that she didn't keep this value negative or minus. Connor made the mistake in that he didn't catch that the scale factor for this y-axis was 2. So really, that value should be -6, not -5. So he was off by 1 in his vertical translation. OCL was very close with his. He got the -2, which is great, and the -6, but he added that negative sign in front, which you aren't supposed to do because our parabola is opening up. So that should stay positive. Remember, having a negative value means that your parabola opens down or is concave down. And then Ben switched his H and K values. He got them mixed up. That should be a -2 and then a -6 on the outside. So now here's our new set of notes. And we're not going to worry about the Desmos portion right now because we're not in class in person. But what we are going to do is we're going to find the x-intercepts of each of these equations. So remember, to find the x-intercepts, that means we're thinking about what is the value of x if y is 0. Because if we're thinking about a graph, anytime, let's backspace there. Anytime that we're thinking about the x-intercepts, if I'm on an xy plane and I'm looking for the points that are here on the x-axis, what do I know is true about any point on the x-axis? Well, my y value has to be 0. So that means I'm going to set each of these equations equal to 0 in order to solve for my x values. We've talked about this in the last chapter, that if we have something, we can call it A, quantity A times quantity B. If we're saying A times B is equal to 0, what do we know has to be true? What's the only time that we can get 0 when we multiply? What has to be true about one of our numbers? It has to equal 0. So that means that I have 2 possible scenarios that's happening. Either x minus 1 is equal to 0, or x minus 3 is equal to 0. Okay, and I'm going to solve each of those out individually. So if I want to solve for x for this first equation, I'm going to go ahead and add 1 to both sides. So that means x is equal to 1. And again, we're talking about a point that's on the x-axis. So if we're describing the point, we would say the point is, so if that means that I'm on here, if this is 1, that point on the x-axis would be 1, 0. So my final answer for that first point would be 1, 0. And for my second one, same process. I'm going to go ahead and add 3 to both sides. Add 3 to both sides. So that means x is equal to 3. But again, I'm describing that point on the graph. I'll say that this right here is 3. So to describe a point on the graph, I need to give coordinates. So my coordinates for that one would be 3, 0. Okay, so those are my two solutions for that problem here. So my two solutions would be 1, 0 and, oops, let me fix that there. And 3, 0. Go ahead and use that same process for example 2, 3, and 4. Go ahead and use the same process. Find what your solutions are. You don't have to tell me the coordinates. You could just tell me what the x values would be, because we know that our y value for all of these should be 0. But go ahead and take a minute or two and solve out these other 3 equations. Okay, so you should be able to check your solutions now, and that you should have gotten x is equal to -1, x is equal to -3, because again, set those both equal to 0 and solve. X is equal to -4, x is equal to 6. Pay attention at this time for this one here, because it was addition, that one's negative, and this one's subtraction, so this one's positive. And then here, that last one required a bit of extra step in that we had to divide both sides by 2, and then in this one, you should have divided both sides by 3. So we got fractions for that one, which is completely okay. When you graph them, it's possible to get fractions. All right, so what was the purpose of having these numbers factored and solving for their x-intercepts? Well, with quadratics and quadratic functions, factored form is a possible way that a quadratic equation can be presented to you. And that means that the reader is telling you with factored form, you can go ahead and you can solve for the x-intercepts. So if it's important for us to know the x-intercepts of a problem, factored form would be the easiest way to write out the equation so that it's quick for whoever's reading the information to solve for the x-intercepts, because then they would just set each of those pieces equal to 0, like we just did in the last slide, to solve for those values to be able to graph them. And then just keeping in mind with factored form, you also always have the a value in front, which, remember, our a is just our scale factor, so that's just telling us how wide or how skinny our parabola is in comparison to the parent function. Okay, so if it's important for us to know what our x-intercepts are of the parabola, it's best to show your equation in factored form. So it just makes it very easy for the reader to solve for those values. It's also possible, I just chose an example where we have 2. It's definitely possible for us to only have 1 x-intercept, because if our parabola is touching the x-axis at exactly the vertex point, it's only going to touch at 1 point. It's also possible for us to not touch the x-axis at all, because if I have a parabola whose vertex is, say, somewhere up here in this first quadrant and opens up, I'm never going to touch the x-axis. Or I can also have it somewhere here in quadrant 4, and if it opens down or concaves down, again, I'm never going to touch the x-axis. So it's possible to have none, 1, or 2 points that our quadratic equation crosses our x-axis. So now we're going to go ahead and we're going to graph this equation here. F of x is equal to x plus 1 times the quantity of x minus 5. So notice again, it's given to us in factored form because we have two values being multiplied by each other. And so I'm going to go ahead and if I'm trying to figure out how to graph, thinking about the fact that I'm thinking, okay, where does this parabola potentially cross the x-axis? So that means if I want to know where it crosses the x-axis, my y value for sure has to be 0, right? So if I want to know where it crosses the x-axis, I have to make sure that I set this equation equal to 0. So I'm going to go ahead and rewrite it. Instead of writing f of x, I want to know the value for 0 is equal to x plus 1 and then x minus 5. So when does the equation equal 0? And again, we're back to that idea of this is basically saying like I can call this section here A and then this equation here B. And if I'm saying A times B has to equal 0 or 0 is equal to A times B, well, what has to be true? Either A is equal to 0 or B is equal to 0. And again, well, what is A? A is x plus 1. So either x plus 1 equals 0 or, and what is B? X minus 5. Or x minus 5 is equal to 0. We don't know which one is equal to 0, so we have to solve for both. I'm going to subtract 1 from both sides. X is equal to negative 1. I'm going to add 5 to both sides. X is equal to 5. So now I just know for certain two things about my graph. I know that I'm going to have a point in my parabola at the negative 1. So I'm going to say negative 1 is here. We're going to call that negative 1. That is a sloppy graph, sorry. So I'm going to make my point there at negative 1. And then I also have a point at 5. I'm going to say about here is 5. So I have a point at 5. All right. So remember how we talked about with parabolas, the cool thing about them and the unique thing is that there's always an axis of symmetry. So like if I have a parabola, I always know that the axis of symmetry happens going through the vertex. So let's say the vertex is right here. I have an axis of symmetry, right? So I know that this side is the mirror image of this side. Well, if we look at our 2 points that we have, since they both lie on the x-axis, that means that these 2 points are the mirror point of each other because they both are lying directly on the x-axis. That means if these points are the mirror images of each other, that tells us that the vertex has to lie exactly in the middle of these 2 points. So if I have the point 5 and the point negative 1, and I want to find the midpoint of those 2 points, all I need to do is take those two values, add them together. So I'm going to do 5 plus negative 1. And that's going to give me 4. And then because I want to find the middle of them, right, I need to divide it by 2. So I would do 4 divided by 2. That means my x value has to be 4 divided by 2 is 2. So now I know my vertex x value for sure has to be 2 because 2 is exactly in between -1 and 5. And now that I know what my x value is for my vertex, well, look at here. If I know my x, I could just plug that back into the equation that I know and solve for my y value of my vertex. So I'm just going to do x plus 1 times the quantity of x minus 5. And again, I know what my x value is with my vertex. It's 2. So I can go ahead and plug it in. 2 plus 1. And then 2 minus 5. 2 plus 1 is 3. 2 minus 5 is -3. 3 times -3 is a -9. So now I know my vertex is at 2, -9. So we'll say 2 is about here. And we'll say -9 is like down here. Again, very rough sketch since I don't have a graph paper drawn on here. And I'll say here is my vertex point. And then I would connect my points. My point here at the 5 and my point here at the 1. If I connect all 3 points, that definitely should have been a lot more curvy. Let's try again. Well, it's going to be good enough. I'm sure on your paper, since you're not trying to sketch on Pear Deck, your graph will look better, but there we go. And that makes sense because in front of this equation, our a value would be an invisible 1. That's positive, so our parabola should open up. Okay, so there's that. And here's the graph on Desmo, so it's nice and pretty. And then same thing that we just talked about. We found the x-intercepts. Again, the vertex has to be the halfway point between those two values. So we took the average, or we found the midpoint. Same thing in this case. Once we found the average for our x value, we plugged it back in to solve for our y, getting our vertex, sketching out those 3 points, connecting them, and we have our parabola. Now, the second example, the last one we're going to cover today, we have f of x is equal to -2 x squared plus 8. What do you notice? Because remember, if our goal is to be factored, what's something that we can factor out of both of these terms? So you should have gotten that they could both give away a -2, right? Both -2 and 8 can be divided by -2. -2 divided by -2 is 1, so you're just left with x squared. And then 8 divided by -2 is -4. Now, what we have left over, you have two options of how you can potentially solve this one in particular, because if you notice, we're left with an x squared on the inside. So if you wanted to, you could use the x method to factor it. So you could think my a value, my b value, my c value. So you could say, okay, my a is 1. I don't have an x, so that means my b is equal to 0. And then my c value is -4. And you could do the x method, and you could figure out what two values multiply to -4, but add to 0. And then you would divide both of those by 1, which, remember, it's nice when we just have 1 because it doesn't require any extra work on our end at the very end. So I'm thinking of two numbers that add to -4, that multiply to -4 but add to 0. So blank times blank is equal to -4, and then blank plus blank is equal to 0. And you should get the numbers -2 and 2. So -2 and 2. So that means when I factor, I'm going to get x minus 2 and then x plus 2. You could have also noticed that this is just a difference of squares on the inside. Remember, that was one of our special factoring ones we talked about last unit, because you could take, and also wait, let's not forget that there's a -2 in front. We have to keep that in front. So now this is completely factored. Okay, but the other way that you could have solved that, if you didn't want to use the x method, you could have noticed that this is just a difference of squares, because remember, we could take the square root of x squared and just get x, and then the square root of 4 is just 2. So that was another way that you could have thought about it. But now that it's factored, we can go ahead and, just like the last problem, we can first solve for our x-intercepts and then figure out what our middle point is. So if I set this equation equal to 0, I have 0 is equal to -2 times x minus 2 times x plus 2. Okay, and I'm going to go ahead and I'm going to set each of these two equations again, because I have this first equation here, and then I have this other equation here. I can set each of those equal to 0 and solve. So I have x minus 2 equals 0, and then I have x plus 2 is equal to 0. And when I solve those out, add 2, minus 2, minus 2. So again, if I were to be thinking of a graph, that would mean my x-intercepts were at 2 and -2. So I have one, let's say this is 2 right here, and then this is -2 right here. So I have a point at -2, and I have a point at 2. Okay, and then keeping in mind, just like the last problem, these are both lying on the same axes, the x-axis. So that means they're mirror images of one another, meaning that our vertex has to be exactly in the middle. So if I take the middle point between -2 and 2, some of you probably can already figure what out that is, just by looking at the graph, but I'm going to just do the math like we did the other one to find the midpoint. So I'm going to do -2 plus 2 and then divide it by 2, which 0 divided by 2 is just 0. Okay, so now I know that my x value for my vertex is 0. So now I know I have 0, comma, something else. I need to find out what that y value is. So in order to solve for y, I'm just going to go ahead and plug back in 0 to my original equation. So it's now going to be -2 times 0 squared plus 8. If I do the algebra there, 0 squared is just 0. -2 times 0 plus 8. Negative 2 times 0 is 0, plus 8 is 8. So that means my vertex is at 0, 8, which we'll say is about, let's see, it's a bit longer. We'll say 8 is about here. So if I make my point there, this is 0, 8. And then again, I just want to connect all three of my points to create my parabola. This parabola concaves down, which makes sense because notice if we look at our a value from the original problem, it's a negative 2. So because it's a negative number, it should be opening down. But there you go. So we graph this one. In order to graph it using factored form, we first have to factor out the problem, starting with factoring out the multiple they had in common before we use the x method or the difference of squares, whichever of the two you chose, and then solving out for each x-intercept, and then again using that process of then finding the center in order to find where the vertex is going to be. So we're just going to go ahead and stop it there. I'll go ahead and go to the next slide just to show the steps a little bit more clean. So there you have it. Factored form, solving for the x-intercepts, and then from there solving for the vertex, and then here's the sketch using Desmos. Okay, so we're just going to end it there. I will see you all technically Thursday, which is, well, not technically Thursday. I was meant to say technically tomorrow because you're watching this on Wednesday. So yeah, I will see you all tomorrow. Please remember though, you can always stop by office hours on Thursday or even on Friday if, even after we talk about this during class and clarify anything, if you're still stuck, you always have office hours to come talk to me. But I hope you enjoy your Wednesday. Bye.